Welcome to the notes for lesson 8.5, multiplying to find area. In these notes, we are going to review the concept of area and discuss how we can use fraction multiplication to find area. So to start, let's review the idea of area. So I'm going to imagine I have a shape. Go ahead and draw it with me. Here is my shape. I'm going to tell you that my shape is 2 units long and 5 units wide. So to find the area of a shape, I'm really talking about the surface. So I'm going to shade that in with my yellow highlighter. When I say area, I mean like I'm covering a flat surface inside. I'm not walking around the outside. I'm covering the whole inside surface. And so to find area, I'm going to multiply my length times my width. So for this shape, the area will be 2 times 5, which is 10. And then I need to put my label. Since I'm multiplying units by units, I can write 10 square units. This is the idea of area. However, in this unit, you're going to encounter area for shapes that look like this. Let's say this shape is 3/5 of an inch long and 7/8 of an inch wide. And they want to ask you for the area. Remember, just like before, area means the flat space inside. I want to know how much flat space. Sometimes it helps to think of area like the surface of a piece of paper. Area can be used to describe paint going on a wall, seed being spread in a garden, cement being poured out, any flat surface. Well, if we go back to our definition of area, we can say area equals length times width. That didn't change just because I'm working with fractions. So to do this work, I'm just going to multiply my length, which is 3/5, times my width, which is 7/8. We learned this strategy in an earlier unit, so it's not really stressful. 3 times 7 is 21. 5 times 8 is 40. So the area of this shape is 21/40, and then I have to consider my label, which is inches squared, or you could have also written it like square inches. Let's try one more together. Actually, you know what? Let's try 2 more together. And then I want to show you what we can do when we get to more complicated ones. All right, I've got 3/5 of an inch times 7/8 of an inch up here, so let's try another one. Let's do a shape that's 1/2 by 1/2. 1/2 foot by 1/2 foot. It's a square. First of all, if I want to find the area, I want to think about what that means. And I can consider that as that flat space that covers the whole thing. To find the area, I know area equals length times width. So I'm just going to multiply 1/2 times 1/2, and I get 1/4, and then I'm going to think about my label, which is square feet. All right, let's do one more. Let's imagine that we have a skinny piece of land for a park. Let's imagine that this park is 7/8 of an acre wide and 11/12 of an acre long. Just like before, area equals length times width. So I'm just going to multiply 7/8 times 11/12. 7 times 11 is 77. 8 times 12 is 96. And my label is square acres. And if you want, you can go ahead and color that one in too. Just to remind you, area means the flat surface inside. All right, now let's consider how we would find the area of a more complex shape. Let's think about this shape. Now, right now you might be saying, that shape isn't more complex, but what if I do this? What if I say I need to find the area of the floor of a bedroom so I can put down carpet? And this bedroom is 8.5 feet wide and 3 2/3 feet long. What is the area of this space? So let's think about that while we color it in. Make sure if you're coloring that you can color with something that's going to allow you to write over the top of it. So if you're going to use your crayon, maybe hold off for a minute, or you can use a highlighter or colored pencils for a second. All right, sorry for my messy coloring. So let's think about this shape for a minute. I have 8.5 feet by 3 2/3 feet. I'm going to use a strategy you've probably seen before, but maybe not with fractions. I'm going to think about 8.5 as being 8 1/2. And then I'm going to think about 3 2/3 as being 3 2/3. So to think about this space, I'm going to start over in this big area, which is really 8 times 3, which we know 8 times 3 is 24. And then this space in here is really 8 times 2/3. Well, I can write that as 8/1 times 2/3, which would be 16/3, or 5 1/3. And then in the top, I have 3 times 1/2. And when I do all the rewriting, I get 3/2, which is equal to 1 1/2. And then down here in the corner, I have 1/2 times 2/3, which is equal to 2/6, which I can leave right there. So what I've done here is I used the area model, but with fractions, to try to consider all these different pieces that I'm working with. And now I want to put them together. I have 24 plus 5 1/3 plus 2/6 plus 1 1/2. So let's do some regrouping. Let's put together our whole numbers first. Those are easy to add together. I've got 24 plus 5 plus 1 more, so altogether that's equal to 30. And I still have these fractions, 1/3 and 2/6 and 1/2. So looking at all of this, I can see that my answer is going to be bigger than 30. Not a lot bigger, but it's going to be 30 and a fraction. Maybe I can put my fractions together and get a whole number, so I could be 31 and a fraction. But I know my answer is going to be around 30. Let's do some thinking about least common multiple so that I can rewrite these fractions. I'm going to write it over here to the side. I have 2 and 6 and 3, 2, 4, 6, 6 and 3 and 6. Well, that makes it easy. I'm going to use 6 as my common multiple. To turn my 1/3 into sixths, I'm going to multiply it by 2 over 2. So now I have 30 I'll bring down. My 1/3 I'm going to rewrite as 2/6. My 2/6 is already sixths. My 1/2, if I want to turn that into sixths, I have to multiply it by 3 over 3. So that gives me 3/6. Now that I've got common denominators, I can add it together. That gives me 30, 2/6, 4/6, 5/6, 7/6. And I can rewrite that. That 7/6 gives me one more, so that's like 31 and 1/6. Now that was a lot of work to do one multiplication problem, and some of you have noticed that there's an easier way. So I'm going to go back to the easier way strategy some of you have told me about. I'm going to start with my 3 2/3 times 8 1/2, and I'm going to rewrite each of these fractions as a mixed number. So 3, if I cut it into thirds, that's 9/3 plus 2 more, I've got 11/3, times 8, if I cut them into halves, that's 16, plus 1 more is 17 halves. I'm ready to multiply. Now I don't have 11 times 17 memorized, so I'm going to use a little space over here, and I'm going to do some standard algorithm. 1 times 7 is 7, 1 times 1 is 1, 0 the hero, 1 times 7 is 7, 1 times 1 is 1. That's going to give me 187 over 6. Now, I don't have 187 divided by 6 memorized, so I'm going to use my long division. 187 divided by 6. 18 divided by 6 is 3. Bring down my 7. 7 divided by 6 is 1. I have 1 left over, and I'm still trying to divide that 1 by 6. So that's going to give me an answer of 31 and 1/6. So just like up here, where I use the area model to show my thinking and do all my multiplying, I can also just rewrite it as an improper fraction and multiply. Either way, whether I'm working with an area that's only whole numbers, an area that's only fractions, or an area that works with mixed numbers, the big idea is to find the area, I just have to multiply length times width.